adventures of Math Girl. With the help of Pocket Ronnie, you also can become a trusty sidekick of Math Girl, like Kid Calculus and the Daring Derivative. Okay, we're going to be doing mixture problems, and if you have taken chemistry, then you will be familiar with this. If you have not taken chemistry, this is a good practice for when you do take chemistry. These problems are going to be worked very similar to the coin problems, to where you have two unknowns and two equations, and your two equations will be how many and the value. So if we're looking at 28b number 8, a chemical company has an order of 80 liters of a solution of 7% HCl in water. HCl, hydrochloric acid. One of its available solutions has 15% HCl, and the other has 5% HCl. How many liters of each solution should be used? The key on these problems is to find out what you have and what you need. So this chemical company needs 80 liters of 7% HCl because they have an order they have to fill. So that's what they need, okay? That's what they're wanting, that's the need. My recommendation is to draw a picture. So this is what they need, okay? They need a solution that is 7% HCl, okay? This is a solution to where 7% HCl, which means the other percent is 93% water. Okay, I'm not going to label that. I'm just labeling the 7% HCl. And we're told that they need 80 liters of that. Lowercase cursive L for liters. Now, what do they have on hand? On hand, we're told that they have a solution that is 15%. I'm exaggerating my lines of where 15%. Obviously 50% would be drawn halfway in the middle, okay? But I'm exaggerating so you guys can see my numbers. We are told that they have 15% HCl on hand, and they also have a 5% solution of HCl, okay? We need to know how many liters of each one of these. How many liters of this do they need? How many liters of this do they need? Because they're going to add these two solutions together to make that solution. This is what they have on their shelves. So we need to know how much of this do they need to add to how much of this to be able to make this, so that they can send it out. Okay? So we don't know how many liters. That's what we're going to calculate. How many liters of this? So I'm just going to call this 1. This is my first solution. You can label these anything you want to, okay? I'm going to label that one 2. This is my first solution. This is my second solution. So, again, just to reiterate, what we're doing is taking one of our solutions that we have on hand plus the other solution. We're going to add those together to make what it is they need, okay? Once you get your picture, then you can draw your equation. Write your equation. Your first equation is, I just label it as how many. That's going to be how many or how much. If you want to write the word much, that's dictated by our liters. So we need a total of 80 liters. We don't know how many liters of this yet, and we don't know how many liters of this. So I'm just going to call this liters of 1 plus liters of 2 equals 80 liters. Again, you can label this whatever you want. In the book, I think they call this S1 and S2 for solution 1 and solution 2. You can label it whatever, okay? My S's look like 5s, so I'm going to use L's. Then your next equation is the value, okay? The same as what we use for coins. How many or how much, and then the value. Well, for this one, for every liter, I'm going to have 15% HCl. Okay, so I'm going to have 15% for every liter, 15% times each liter. Then for this one, I'm going to have 5% HCl, 5% for every liter, so 5% times my liters equals, down here I have 7% times for each of my liters, and I am told that I have 80 liters. So just like in your money, you took the value of each coin. Here we're just taking the percentage of the solutions, or a percentage of what we have. But in math, you cannot work with equations with percents. You have to turn your percents into a decimal. Any percent is out of 100. So to turn 15% into a decimal, it's 15 out of 100, meaning 15 divided by 100, which is 0.15. Any percent is divided by 100. So this new equation becomes 0.15 L1 plus 5% divided by 100 is 0.05 L2 equals 7% divided by 100 is 0.07 times 80. Okay, so now I can stack my other equation, my second equation, which was my how many, L1 plus L2 equals 80 liters. Okay, now I'm going to do the same thing, elimination, to try to get rid of one of my variables. First, I'm going to combine these two numbers together. 0.07 times 80 is 5.6. Okay, so now I want to add these two equations together to eliminate one of my variables. It doesn't matter which variable you eliminate. You can eliminate L1 or L2. It doesn't matter which one. I'm going to choose to eliminate L1. Well, if this is a positive 0.15, then I need to have a negative 0.15 multiplied to it, which means I have to multiply everything by a negative 0.15. I use my parentheses to remind myself I am multiplying. Okay, so I'm going to rewrite my equations. So here I have 0.15. This is my top equation. I didn't change it at all. Equals 5.6. My bottom equation is the one I was multiplying everything by negative 0.15 plus, or that would actually be minus 0.15 L2 equals, now it's a negative 0.15 times 80, which was negative 12. Okay, now I'm adding my equations together. A positive 0.15 and a negative 0.15 is 0. Now I've got a negative 0.15 and a positive 0.05, which is a negative 0.10 L2, and then negative 12 and adding it to 5.6 is negative 6.4. These answers should come out positive. This is good. Now I'm solving for L2, so I'm dividing both sides by negative 0.10. Your answer should come out positive. Negative divided by negative is a positive. So that is 64. And what is it that the units are important in these problems. Okay, the units are very important. So what is it that I was solving for? How many liters of this second solution did I need? Okay, I needed 64 liters. So from our picture, that was our 5% solution. Okay, so now I can go back and determine how many liters I need of the first solution. So remember, my equation was L1 plus L2 equals 80. Can you come back up to here? My original equation of how many was L1 plus L2 equals 80, because the idea was how many liters of this, so I just solved that I need 64 liters of this 5% solution. So now I can determine how many liters of this do I need to get 80 liters. So if I know that L2 is 64, then it's just a matter of solving for L1. Subtract your 64 over. And so that means that for the first solution, which was the 15% HCl, I need 16 liters of that. So it's really important, put your units on here and then keep up with how you labeled it, okay? L2 was my 5% HCl. my L1, and I used L for liters. You can use whatever variable you want. My L1 was my 15% HCl. You can label these as L5 if you want it to be 5%, and that could have been labeled L15 for 15%. However you want to label it, as long as you keep up with, and then when you write your answers out, your answers are clear to that this is 64 liters is for your 5% HCl, or 64 liters for 5%, 16 liters for your 15%. So just make sure that your answers are clear of what it is you need. Okay, we're looking at 28D, number 9 and 10. Jeff needs 100 gallons of 4% chlorine and 96% water for his pool. He has two solutions, one that is 7% chlorine and another that is 3% chlorine. How much of each solution does he need to make the desired solution? Okay, again, you got to break it down into what do they need, what do they have on hand, okay? Jeff needs 100 gallons of 4% chlorine, so he needs 4% chlorine. 4% and chlorine is Cl. He needs 4% chlorine. This is what he needs. And he needs 100 gallons of that, okay? The other part is 96% water. 96 plus 4 is 100% of the solution, okay? So, but I'm interested in the chlorine since everything talks about chlorine, so I'm not even going to label the water, okay? So what is it that he has on hand? This is what he needs, but this is what he has. Okay, we are told that he has 7% chlorine, that's 7% Cl, and he's got 3% chlorine. I'm just drawing that line a little lower, so that's 3, that's a 3, 3% chlorine. This is 3% chlorine. I'm just switching colors because my purple's running out. We need to take some of this and some of this, add it together to make that, okay? But we need to know how many gallons of each. This is in gallons, so therefore I'm going to measure these two in gallons. So I need to know how many gallons. So I'm just going to call this gallon 1 and gallon 2. You can label it whatever you want, just so you know. The book labels it CS, that stands for chlorine 7%. Then the book says C for chlorine and then T for 3, so you don't have too many numbers. So they call this chlorine S, 7% chlorine, 3% chlorine. So you can use whatever labeling you want. I'm going to use G1 and G2. This reminds me I'm needing gallons. How many gallons of this and how many gallons of that? So my first equation I'm going to write is my how many or how much, okay? This gallons plus this gallons has got to equal 100 gallons. Do you see where I'm writing all my variables? I put these outside here because I'm using this outside number here, okay? So I'll take the gallons for the first solution plus the gallons for the second solution has got to equal 100 gallons of what he needs. I'm going to take some of this and dump it in here and some of this and dump it in here, and it's got to equal 100 gallons. Okay? Then my next equation is going to be the value. So this very first solution I have is 7% chlorine. So for every gallon I have of that, it's 7%. 7% times every gallon I have of that. And then for my second one, it's going to be 3%. I'm going to multiply it, 3% chlorine for every gallon I have. Every gallon I have of that is 3% chlorine. So it's 3% of that. Then for my last one, this of what I'm needing is 4%. 4% chlorine times every gallon, which I know how many gallons that is. That's 100 gallons. So I have my two equations and two unknowns. Now I just need to clean up my equations a little bit. This one, I need to get the percents out of there. You cannot work with equations with the percents. You have to turn your percent into a decimal. Any percentage can be changed into a decimal by dividing it by 100, because 7% means 7 out of 100, which means 7 divided by 100. So 7% is the same thing as 0.07. So times my G1 plus 3% is 0.03 G2. And then now I can multiply this. 4% is 0.04 times 100. So my 0.04 times 100, or 4% of 100 is 4. So that is 4. Okay, I'm going to rewrite my how much equation with that. It doesn't matter which one's on top or which one's on bottom. It doesn't really matter. Okay. So that was my first equation. I need to add these together so that one of them will eliminate. It doesn't matter which one you eliminate, if you eliminate G1 or G2, okay? But I'm going to choose to eliminate G1, which means this needs to be a negative 0.07. If I multiply negative 0.07 to this one, I have to multiply negative 0.07 to every one of them. Because now a positive 0.07 and a negative 0.07 will be 0, and that will cancel. Okay? So just let me rewrite my equations to make it cleaner. So this was my very first equation. I didn't change anything on this top one other than multiply the decimal and the number together. Then on my second equation, I'm going to have negative 0.07 G1 plus negative 0.07 G2, and then I'm multiplying negative 0.07 times 100, and that is a negative 7. Adding my two equations, G1 goes away. Make sure you make this a 0.07 and not just a 0.7. So a negative 0.07 and a positive 0.03 is a negative 0.04. Keep up with all your decimals. And then that would be a negative 3. Now solving for G2, dividing both sides by negative 0.04. I should be dividing by negative because I want to end up with a positive answer. You should not end up with any negative answers for these. So, and it's okay if you end up with a decimal on these answers. So, a negative 3 divided by 0.04, you're putting this in your calculator first. This divided by this in your calculator came out with 75. Well, what was it that I was looking for? What did this represent? This represented the number of gallons I needed for my 3% solution. Okay, so 75 gallons, that's my units. And then, just to make a note, this was for my 3%. G2 was for my 3%, oh, not HCl, chlorine. Okay, that was chlorine. So, remember my how many or how much equation was G1 plus G2 equals 100. So now I can take this and put that in for G2. So I can solve for G1. Subtracting 75 to the other side, that I can see that G1 is going to be 25, and that's gallons. That's what that represented. And that was for my 7% chlorine. It's good to keep these all good and labeled so you know what it is that represents. Because if you went and told your boss, or you told someone G1 is 25 gallons, I don't know what that means. But if you told someone I need 25 gallons of my 7% chlorine solution, now I understand where to go look on the shelf. I know to go get 25 gallons of this solution and then 75 gallons of this solution. I'm going to add those together, which will create, when you add those together, you're going to create what he was wanting. He wanted 100 gallons of 4% of that.